Good afternoon, good evening, good night, good morning, depending on where you are in the world. This is Dr. Ferdinand. We are about to begin our GAMSAT tutorial. So, for some perspective, this is the beginning of GAMSAT season. You are nice and early. On average, uh, for a successful score, on average, students will study 3 to 6 hours a day for 3 to 6 months. So right now you are in the proper window in order to have a successful outcome. Now, of course, having said that, that's average. There are some students who can study just a couple of weeks and end up with a successful score because they have a long history of reading fiction um, and books in general, and or they have a degree in arts or a minor in arts or English literature, philosophy, history, and they have very good natural science reasoning. As long as they're given the basics, they can figure things out. Doesn't mean that they have the highest grades. It's just that they're insightful, can do well with relatively little study, but they're very rare. Most people, 3 to 6 hours a day for 3 to 6 months to get a successful outcome. Now, if you don't have any science background or if you don't um, have any history of writing essays or so on, it may take a little longer, It really does depend on your individual circumstance. Now, for today, uh, we do have a forum anytime you want to ask questions about any of the questions we're going to be doing, because every time, at Gold Standard GAMSAT, we have monthly free webinars. We also have tutorials starting weekly, 3 hour long tutorials. Our free webinars like today, it's about an hour long. And the tutorials begin in December, so next month. And those are weekly, going right up until the exam in March, the next exam. And as a parallel to that is what we're doing today. And all of our webinars and tutorials have problem-based learning. And I know some of you might not want to look at any problems. You might feel it's too early for that. Teach me what I need to know first, et cetera, et cetera. But you've got to, sort of jump into the deep end, feet first, and flail a little bit, make some mistakes. But what it allows you to do, it allows you to better understand these these statements that you've heard again and again. GAMSAT is not a memory exam. It is a reasoning exam. Easy to say, but there are some people who've sat the exam multiple times and still cannot fully understand to the degree to which that's true. And so they waste time. They waste hours, days, weeks, months studying information that is completely unrelated to the exam because they think they have to know this biological fact or chemical fact in order to understand what the passage is saying. And of course, that's true to a degree, but the key is to understand to what degree. And so today you're going to get a taste of that. You're going to look at some problems, some of which will cause you problems, and some of which you might find, basic or straightforward, I hope. But some of them you will note some challenges, and it's because the language is such that you may not be accustomed to the way things are being presented. But in the end, after you've gone through these problems, you're going to see that in order to obtain the solution, and we will discuss the work solution, um, you just will need to have a basic understanding of the facts. And I understand some of you may have an arts background and so on, but you're going to still be able to answer some of the questions correctly. Okay, so what I'm going to do first is I'm going to just try to orient you in terms of the relevant material for today, because today we're going to be discussing dimensional analysis. That's what you're going to be using. And this idea of dimensional analysis, which I will present to you, is used on every single GAMSAT. So every exam is going to be using this concept to one degree or another. And once you master this concept, you will be able to answer real GAMSAT questions on the real exam correctly without even fully understanding the question. What? So, so obviously that's a very useful tool. And this is not magic or some secret. People who have experience with the exam understand how Acer emphasizes units and manipulating units in order to obtain the correct answer. So this is one of the techniques that you'll be practicing today. And of course, like all of our webinars and tutorials, this is being recorded so you can watch it later on YouTube or going back to the Zoom link that brought you here in the first place. So usually it takes an hour to a little time after the webinar for it to be live and accessible to you. So you can watch things later. So if there's something you didn't get during the tutorial itself, then you can just watch it later and get clarification. And you will also have access to our forum later. So you'll just be able to go to the forum and post your questions there, and you'll receive an answer within usually 24 hours, something like that. So, I've written 7 GAMSAT books, and you're just looking at one of them here, which is the Maths and Physics book. And I'm just going to orient you a little bit. You know, of- I think you already know how the exam is. I'm not going to waste your time on that, but you know that it's now divided into 2 test days, one for the written communication, your essays, and then one day for the multiple choice sections, humanities and social sciences, and reasoning and biological and physical sciences. So uh, we're going to be talking about dimensional analysis, which classically, it's taught in our physics, math and physics book, because that's classically where it is taught. But however, this technique, you're going to find that you'll be able to answer questions in physics, general chemistry, and biology using dimensional analysis. So there are some biology graph interpretation that requires dimensional analysis. So it's a powerful tool. Only organic chemistry doesn't use it. Everything else does. And this is, basic outline of the exam itself and how things are broken up. And now for the exam, I want you to spend a moment to read a box over here. So you can use your smartphone to take a pic of your screen or a screenshot if you're watching this on your smartphone. And you can read this. I'm just going to give you 30 seconds to read this box, please. Okay, so these are from student debriefs, students who, comment on the experience of the real exam after the real exam. And I have to say, every student has a different experience. It's based on your life experiences before the exam. And also, uh, Every exam is not identical. So you might be at a particular test center, and the person sitting next to you might have an exam with some different questions or some different graphs. Um, so you might have more graphs, the other person might have not as many. So there's internal security for the exam and all kinds of other issues that lead to that. But generally speaking, mathematics, even though it's not formally a title of a section of this exam, it's it's imperative that you spend time studying it because it's a very important part of your preparation for the exam. Generally speaking, when you're preparing for this exam and preparing for sciences, this is how you should study. You start with mathematics, make sure that you can do um, calculations quickly. No calculator is permitted for the exam. And you have to deal with exponents and fractions and sometimes simple equations, but sometimes more complex equations and equation manipulation and dimensional analysis. So mathematics serves as the foundation for all the other GAMSAT sections. You're not going to be able to properly solve GAMSAT biology questions, especially in terms of graph analysis, without having a foundation in how to analyze graphs. And that's mathematics. So, and it goes as well for many general chemistry problems and physics problems. So it has to start with mathematics. Of course, you can get it anywhere. You can get it in Khan Academy. You can get it. Um, uh, you can just Google. You can use AI to get a basic understanding. But of course, we've simplified the process by writing books and ebooks and creating videos that cover all the sections of the exam. And and one of the things we do. Oh, and by the way, I know you might be thinking, oh, it's too expensive or things like that. But there are many libraries in Australia, UK, and Ireland that have our books, including new editions. And even when they have old editions, when they're told, they usually get the new editions of our books. So you have many options to access the latest content to reflect the current um, uh, exams. So we always say what you need to memorize, what you need to understand, and what is the relative importance of every chapter, not based on my personal opinion, but relative importance based on real past GAMSAT questions as released by ACER. And we have exercises to make sure that you have the basics needed to manipulate. And if you don't, then we have the explanation starting from the beginning of the beginning, the most simple ideas, how to add and subtract negative numbers to multiplication to fractions to manipulating exponents and et cetera, practice questions. So this is what we'll be looking at. This is a chapter on scientific measurement and dimensional analysis. So, and dimensional analysis is you paying very close attention to the units and how to manipulate mathematically in order to get to the units of the answers. So we're going to be looking a little later at this concept that when you're trying to change units from one set of units to another, say, for example, you start with days and you want to change days to minutes, and you need to change those units. Well, you're going to be doing a sequence of multiplications, and each time you're going to be multiplying by the number one because you can multiply anything by the number one and you don't change it, right? So you're going to be multiplying by the number one, but you're going to be modifying that by information that you already know. You already know 60 minutes is in an hour. Or you can write 1 hour represents 60 minutes. You can write it 1 hour is 60 minutes or 60 minutes is an hour. But either way, this is equal to the number one. And that means you can multiply any number, any number with units by either of these in order to change the units to something more useful. So don't worry, you're going to have um, a real example, using the standard that Acer uses in order to do that type of calculation. And then, this is the most important chapter that you're going to read for GAMSAT, bar none. Doesn't matter if you're talking about written communication, humanities, any of the four sciences. The most important chapter is not a chapter on cellular physiology. It's algebra and graph analysis. Two tools that you'll be using in three out of the four sciences in the GAMSAT sciences section. So it is critically important that you have a clear understanding of logarithms, for example, manipulating logs, manipulating equations, different types of equations, and then understanding graphs. And that's not something we're going to be doing today, but we're going to have a separate free webinar in the future about graph analysis, understanding how to, in order to interpret the types of graphs that Acer likes, and little tricks that Acer likes to do, like breaking graphs at some point, making sure that you understand that. Sometimes Acer uses three-dimensional graphs, in different ways. And of course, logarithmic curves. Acer can present these in many different ways, and understanding how to solve that. Some curves graphs don't even look logarithmic, but don't look on the surface, I should say, but you will understand how they are logarithmic, even though Acer doesn't even use the word log anywhere in the problem. And if you don't pick that up the way it is presented, then you can't solve it. And then there's a whole form of graph that is rarely seen in introductory level sciences. So it makes it more equal for art students and science students because neither of them usually have seen these types of graphs, and they're called nomograms. These are graphs with multiple axes, so more than two axes in order to solve. And Acer loves these because it tends to be a type of diagram the students aren't used to. And this is a famous triangle graph that's appeared almost every year for many years on the exam, which is also, it's not intuitive how you solve it. And as I said, it's been on real exams. So that's a graph analysis. And then the rest is basic, starting physics from the very beginning and going up to more um, uh, you know, complex physics relevant to the exam only, not veering left or right on that issue is, typically information is presented, an equation is presented, and then you have to do manipulations in order to solve the problem. And of course, there's going to be all kinds of uh, types of graph analysis with multiple choice questions. And throughout the books and the sciences, there's always a spoiler alert at the end of every chapter. And it, because one of the things students are worried about, they don't want to memorize equations that are unnecessary. So what we do is we make sure that if we have questions that required you to memorize an equation, that there's a real past GAMSAT question that did that required, as we will see today, MGH or 1/2 MV squared, or one of the standard, very, very basic equations. So if Acer in a real exam required you to know that, then we will make sure that you have been practicing that, which you will get to do today. And don't worry if you haven't heard of those equations, I'm still going to give them to you. But there's still going to be some problems that you'll be able to answer without knowing those equations. Okay, so I'm going to ask Viv, my assistant, if she can give the link to today's practice questions. So she will give the link in the chat so that you will access the practice questions. Um, and we're going to have a timer so that you can complete the practice questions within the allotted time. And then we're going to discuss the worked solutions. So we'll go through the answers, discuss the worked solutions, and I will complete them in front of you. While you're working on these problems, instead of just looking and not trying, okay? Because I know some of you are going to look at some of the problems and you're not going to want to even try it. And you're just going to wait for the work solution. But really, the way you prepare for this exam is you just slog away. You're going to make a lot of mistakes at the beginning, and then it's going to get better and better as you better understand what's being asked and how to sort of find your way through that forest. Because although it will feel like a forest sometimes when you sit the real exam, the truth is ACER is going to leave a breadcrumb trail, and you just have to follow it. You have to follow it in order to uh, find your reward. So the first page of your handout, it's just some blah, blah, blah about where you can get more information about videos or books or even our free medical school interview program for those of you who will be getting interviews. We have a free program on our website, and there's no pay for premium. It's always free, and we have videos to teach you how to deal with the interview, both one-on-one interviews and the MMI. But that's not what you're here for today. We're going to go through the basic questions, which you'll find starting on the second page. Now, there are 5 multiple choice questions, and the way it currently works is that you have 2 minutes per question in the sciences section. So, of course, in the humanities section, you don't have that much time. You have 1.5 minutes per question, but in the sciences, you have 2 minutes. And you have to get used to understanding these restrictions so that you're able to um, uh, time yourself during the exam every half an hour. Make sure that you've finished 15 questions. And in future webinars, we'll talk about that in more detail. Right now, we're just trying to get you to do some practice questions in dimensional analysis, one of the foundational principles for this section. Now, for these 5 questions, feel free to consult a book or Google or whatever you want, AI it, but try to work through it and think through it. Don't just stare at problems and not even give an effort. Now, normally it's 2 minutes per question, but today, we're going to make it 8 minutes. I put 7.5 minutes on I'll round it up to 8 minutes. And so we're going to be giving you 8 minutes to complete these 5 questions. The reason why is that usually on the exam, there are some independent or discrete questions like what you're about to do, but many of the questions have passages and you have to interpret a graph or table or diagram. And so that consumes time. So you're going to not have to deal with all those additional issues. Now, I have some hints that I'm going to be putting up here in a moment. I don't want to put them up right now because I don't want you to be thinking about that yet. I want you to try the problem. And if you struggle with a particular problem, then you can look at the hints that you will be able to see up there. If you don't need the hints, don't look at the hints. Just give it your best effort. And then after 8 minutes, we will go through the work solutions. Okay, can we get a clock for 8 minutes? Can you do that, Viv? Okay, so let's begin and good luck. Okay, so those are your 8 minutes. I'm sure most of you have not been able to finish. It's okay, no problem. This is a process. You're at the very beginning of your experience, and with time, you will become more efficient because you will be expecting certain question types, and that's going to make it easier. So we will see some of these hints and how they apply to problem solving, but let's begin with the first question, which is the refractive power of a lens. So if you wear glasses, you might know you have a prescription for your glasses that are plus 2.5 or minus 2.5 or plus 60 or, or whatever, depending on um, your level of vision or absence of vision. So this is all measured in diopters. So we're told about so in in basic physics, students learn what diopters are and the power of the lens, but Acer is not saying that you need to memorize that. So they're giving you the information. Now we need to present it in a mathematical way and then solve it. So they're telling you that the refractive power of a lens uh, in diopters. So now we are told of something called diopters, and and it is the inverse of the focal length in meters. So inverse means so it's 1 over f, where f is the focal length in meters. So I mean, you're not going to get an easier equation on the real exam. And I know some of you are thinking, but they wouldn't ask a question like that. Yes, they've done. They've done exactly that. They've asked questions in which all you have to do is take the inverse and manipulate the numbers slightly. A classic example is the relationship with frequency and the time period, which is an inverse relationship. So in one real past exam, when the question was released, uh, Acer just gave the micro frequency or mega frequency. So it's just going to be a manipulation of one of the units, and then you had to take the inverse. So you had to make two distinct steps. So here, we'll just focus on this for now. We have diopters is 1 over f because we're given that information. And we're told that f has to be in meters. So let's keep that in mind. And then we're given that the refractive power of the object that we're asked for it, if the focal length is 0.50 centimeters. So we have 1 over 0.550, we don't have to write the last zero, centimeters. So, but we're told it has to be the focal length in meters. So we have to convert to centimeters. So centimeters, of course, it's 100th of a meter, 100th of a meter. So that means we have 0.5 times 10 to the minus 2 meters. This is dimensional analysis. We're paying very careful attention to the units and we manipulate them according to a formula or some relationship that is being presented to us. So now we have exactly diopters and the inverse of the focal length in units of meters. So now we just need to convert this. And so 1 over 0.5, well, that's just the number 2. And 10 to the minus 2 in the denominator, if we want to bring this up, we change the sign of the exponent. So if you have minus 2 and you bring it up, it becomes plus 2. If you have plus 2 or just 2, you bring it up, you'll have minus 2. So now we have this in units of diopters. So of course, this is 200 diopters, and therefore the answer is D. coincidence for the D. So the answer to question one is D. And as I said before, this is all is going to be recorded so that you can watch it later if you have any issues. But this is very basic manipulation. This would be one of the most simple questions that you would have on the exam, basic equation manipulation. Okay. So now let's graduate to a little bit more mathematical work, keeping in mind you can't use calculators. And we're going to move on to question number two. So question number two, which of the following is consistent with the average rate of increase in the height of a person from birth to 20 years old? Now, I know when you read something like that, you might instantly think, what an insane question. I mean, why am I trying to do this for medicine? What does that have to do with it? Well, every major hospital in a major city has medication errors every day. And that's often, especially in pediatrics, and it's often due to not being careful enough with units. And so there are many different types of questions that are designed to make sure that you understand units and you know how to manipulate them accurately. And of course, without a calculator. So, and when looking at a question like this, you might think, how am I supposed to know the rate of increase of and so on. But if you look at the answer choices, you see that the answer choices are different from by 100 times. 100 times different from each other. So it's not as if the answers are off like 2% or 5% or something like that, where you have to be extremely precise. They're 100 times different. That means you could be just vaguely, understanding of what would be reasonable, and you would still get the answer correct. And I know that might sound vague for now, but once you've done the calculation, then you'll understand what I mean from that. And just to be clear, you know, we're talking about the rate of growth of a person from birth to 20 years. In past exams, some questions have been released. ACER is asked about the rate of growth of your nails in meters per second. Right, your nails, without giving any information whatsoever about how fast nails grow. But the answers are so far apart, you can make a reasonable assumption in the end. So there's a lot of things going on here. There's math, there's approximations, and there's reasonable assumptions. Um, okay, so let's try to figure out how we're going to do this. I'm looking at the answer choices, and obviously I have no idea which of these answer choices is going to tell me. I mean, it's in meters per second, how fast a human being is growing. It's absurd to be able to just look and understand it. But what I can do, I can just randomly choose one of the answers. And by the way, you're going to have some uh, two A4 sheets of paper in order to complete your calculations. So scratch paper or scrap paper, whatever you want to call it. So you'll have two A4 supplied by the test center, so you can do your calculations. So I hope that you've tried at least to do this, but we will go through the calculation. So I think I'm going to do it this way so that I just have a little bit more space. So first, I'm going to take answer choice A arbitrarily. 2 times 10 to the minus 7 meters per second. And I'm always going to have my units. I'm going to write everything very clearly so that I can cancel things. And so later on in the exam, if I have time, I can come back and look at the question and see if I've done the calculation correctly. So I'm not going to just do things randomly. I'm going to make it very clear. And also during the exam, just a little side note is when you're working on your scratch paper, cordon off your work. Once you finish your calculation, just cordon it off so that your work on other problems don't leak into another problem. So you put the question number over here and then coordinate it off once you've completed your calculation. So to be clear, what I'm trying to do, because I have no idea as to the rate of growth of a person in meters per second. There's no, I mean, but what I can understand is approximately how tall a person might be after 20 years of life. Now, you might say, but come on, there's a range. Yeah, but the range doesn't go from 1.5 meters to 150 meters. There's no human being who's 150 meters tall, right? And there's no human being that's a centimeter tall, 1 single centimeter tall at the age of 20. So because the answers are 100 times different, it means I should be able to come to a height that is rational. And that would be the answer. And of course, it's a multiple choice exam, so you're looking for the best answer. So there's only one of these answers that are going to be in the ballpark. So let's find it. So I'm starting with answer choice A to see where it's going to lead me. So what I'm trying to do is to do a series of calculation to end up with meters. So to cancel out the seconds, to get to how tall is this for a 20-year-old person. And then once I have that number, then I'll know if it's logical or illogical. So these are the type of reasoning that Acer could make you do without having completed a course in physics, even though you're using principles from, well, dimensional analysis, which is really mathematics, but is often taught in physics. Okay, so in order to go from seconds to 20 years, of course, I have to get rid of seconds. And as I mentioned to you with dimensional analysis, I can do this by multiplying by 1. So basically, I'm going to multiply this number by 1 many times so that it doesn't change the value, but it changes the units. So that's going to be the objective. So first step, I'm going to multiply to get rid of the seconds. I know that there are 60 seconds in a minute. And then the seconds are going to cancel, but then I'm going to end up with minutes in the denominator. I need to get rid of minutes because I need 20 years. So then to get rid of the minutes, I'm just going to use a dot for the multiplication symbol. So to get rid of the minutes, I know that there are 60 minutes in an hour. And then to get rid of the hours, I know there's 24 hours in a day. Now to get rid of the days, I know that there are 365 days in a year. Oh, I'm almost there. And now I know how many years there are. 20 years. So now let's see what just happened. I had a number associated with a set of units, but I cannot answer the question correctly because I don't understand what this means. So I'm going to convert it into something that I understand for a 20-year-old. I have to go through a sequence of steps to manipulate the units. This way I can cancel seconds because I have it in numerator and denominator, cancel minutes, cancel hours, cancel days, and cancel years. So my final answer is going to be in meters. The process of dimensional analysis is over. That's it. Dimensional analysis is analyzing the units in order to get the outcome that you need. This is the same thing that pediatricians do with infants that they have to give a certain antibiotic to. They have to manipulate the units in order to represent the actual weight of the infant. And they have to do it very carefully because the consequences, if it's not done properly, would be severe. So dimensional analysis is over. Now we just have to do mathematics. So mathematics, of course, no calculator. And I know you might be looking at this and saying, how am I going to do that in in less than 2 minutes when I have 74 other questions to complete. But believe it or not, this is very simple. And the key thing is before you do any mathematical calculation on the real exam, again, look at the answer choices. If the answer choices are very, very close to each other, then it's dangerous to approximate. But if the answer choices are 100 times different from each other, you can approximate comfortably. So let's have a look. So first step, I'm going to look at this 24, and I'm just going to turn that to 25 as an approximation, because we know it's easier to deal with 25 than to deal with 24. And 365, we're going to turn that to 400. And we're going to be able to do the calculation. And when we complete the calculation, you're going to see that these types of changes have no effect on the answer. Because going from 365 to 400, it's a small percentage change, but the answer choices are 100 times different. So you have that liberty. So now let's see how fast you can do this calculation. So in this, just these two parts, I have 25 times 4, which is 100, and I have two other zeros, two zeros. So 25 times 4, 100, plus the two other zeros. So I'm removing that. And then I'm going to count up my zeros. I have 1, 2, 3, 4, 5, 6, 7 zeros. And here I have 10 to the minus 7. So that means all the zeros cancel. 10 to the minus 7 cancels with the 7 zeros. 1, 2, 3, 4, 5, 6, 7. So that all cancels. So then what am I left with? I have here 2 times 6, and I have here, I have another 6 here. There's nothing here, and I have another 2 here. So I have another 6 here, 6 times 2. So that's 12. So without doing any complicated calculation, and the only thing that slowed me down is that I'm talking. If I wasn't doing that, without any calculation, the zeros cancel, and the most complicated thing I have to do is 12 times 12, and that's 144. Okay, so I have 144 meters. And do you think a 20-year-old human being can be 144 meters tall? Well, of course not. And that's the most difficult decision you have to make. So if I look at answer choice B is 1/100th of this. So answer choice B is 1.44 meters. Now there's something that's in the ballpark, because after all, what's answer choice C going to be? It's going to be a centimeter, 1.4 centimeters. That's ridiculous, impossible for a 20-year-old to be that. And then answer choice D is even smaller, so it's a microscopic human being at the age of 20. So that's not happening. So obviously answer choice B is the best answer. And so this could be a question on hair growth, nail growth, any part of the body in meters per second, and that you do these types of manipulations. And by the way, you can take an entire physics course in university and never have seen a problem exactly like this. They won't usually have assumptions like this. So that's why you want to prepare with a very specific preparation for this exam. Okay, so the answer for 2 is B, and we're moving to question 3, which is the first question that had a hint. And the hint was that current is charge over time. So current is equal to charge over time. So, and time in the SI system of units is in seconds, and charge is in coulombs, capital C. So yeah, current is usually symbolized with a small letter I. So current is charge over time. Now, an issue like this, Acer may or may not give it to you, that current is charge over time. They may not, sometimes they'll do it, sometimes they won't. And the reason they may not is because you should have an idea as to what current is. I mean, if somebody asked you about water, um, you know, you've seen the expression current referring to, say, water in a river. And if someone asked you, well, what do you mean by current? I think if you thought about it for a while, you might come up with the solution that water current has to do with the amount of water passing a point per second. If there's more water passing the point per second, then you have greater current. And if there's very little water passing per second, uh, if you have a lot of water, you have great current. And if you have a little bit of water passing per second, then you have a small amount of current at that place. Well, current for electricity is the same thing. Current is discussing the amount of charge that is passing a point per second, because electricity is referring to charge. Okay, so if we have this sort of concept and we're given the current, we're told a current of 2A, which is amperes or amps. So a current of 2 is passing through a wire for 1.5 minutes. So we're given the current and we're given the time. So I'm just going to move this equation around because now I have I, T, it's not my work, but IT, and that is equal to the charge in coulombs. And I'm given the current in amperes, which is 2, and I'm given the time, but the time in SI units, and this is called dimensional analysis, paying attention to the units. The time in SI units is seconds. So I'm given 1.5 minutes, so I know that's 90 seconds. And this is equal to 180 coulombs. So that is the total charge of the information that I've been given. But that's not what I'm being asked. I'm asked how many electrons pass through the wire. How many electrons? So I'm given the charge on an electron is a certain amount. So I'm going to use that information. If the charge on an electron is that amount, then I can take that information and I can say that there is 1.6 times 10 to the minus 19 coulombs per electron. Okay, so now how do I use that information? Okay, I'm just gonna block this here. I'm given the amount of coulombs. I know how much charge there is per electron. Now I need to divide in order to get rid of the coulombs and end up with just the electrons. And by the way, I don't want you to get caught up in coulombs, amperes, electrons, whatever. Of course, you'll do a revision or review or learn it for the first time, whatever, just to hear the words and to do a few simple calculations. But none of that's relevant. I mean, on the exam, they can use, words that you've never seen of in your life, but you still have to follow those units? What are the relationship with these words that I've never seen in my life? Do I divide? Do I multiply? What do I do with them? So here, I'm going to take that 1.6 times 10 to the minus 19 coulombs per electron. And so I know some of you, you're not used to working with fractions and whatever, you have to practice, and you can go through the book or the videos, but you need to take a pen to paper or pencil to paper and do some practice and remind yourself of some of the rules. So one of the things that I'm doing here, because it's dimensional analysis, I'm canceling the coulombs because it's in the numerator and the denominator. And then if there is something in the denominator, then this pops up as a numerator. So yeah, you can remember it that way. The denominator in the denominator is the same as the numerator. Now, some of you, I know you prefer to do cross multiplying, or you have other techniques that you did in primary school and you need to remember them, whatever floats your boat. But this is one way to do it. Okay, so dimensional analysis is complete. I am now about to write the number of electrons because that's what the dimensional analysis has produced. So, by the way, this is question 3, to be clear, because we already completed question 2. And now I just need to do the mathematics. So divide this 180 by 1.6. So I'm going to do a little manipulation before I do my calculation. Just a very simple manipulation. I'm going to change 1.6 to 160. I'll show you in a second why. So I'm adding here. So if I add here, I have to subtract from the exponent. So I subtract 2 positions because I added 2 positions here. I subtract 2 here. So this is minus 21. And the reason I've done that is because it makes this, the 180, more similar to this. So 180 over 160, I check the answer choices. The answer choices are different by 100, lots of space. So I'm going to say 180 over 160 is the number 1. It's close enough. And then I have 10 to the minus 21 in the denominator. And if I want to bring that to the numerator, I change the sign. So this is times 10 to the 21. Then I look at the answers, and it's A. So this question 3, the answer is A. So you can see 180 is not exactly over 180. It's a little bit more. So it's a little bit more than the number 1. Of course, if you want to really divide it, you could divide it. But, there are tricks so that you can be quick and still, let's say, accurately approximate, especially when the answers are far enough apart. So there's the answer. It's A for question 3. We use dimensional analysis and then use little mathematical tricks to make it as easy as possible. Now, our final question type related to dimensional analysis. We're going to talk, which has these hints for question 4 and 5. So some of you have never seen these equations, and yeah, that's fine. You've never seen these equations before. You're going to have to learn them because sometimes Acer gives them in an exam, sometimes they do not. And so it's important to learn them. There's only a limited number, and we're going to give you a link to some of the equations, that I believe you should memorize for the exam. There's not a million of them, but they're basic ones like this. So this is energy. And there's different ways that energy can be expressed. This is the most famous equation for kinetic energy. And this is kinetic energy means kinetic means movement. So this is the energy of movement. So this is 1/2 mv squared, 1/2 mass times velocity squared. And then this is the famous equation for potential energy, which is weight times height. And weight in physics is mass times gravity. So we have mass times gravity times height, and this is the potential energy. And this is work. So work is also in the same units of energy, which is a joule. You'll learn about this in our videos or in the book. And so this is force times distance. That's the colloquial way to say it, but more specifically, it's force times displacement. But nonetheless, these are various ways that you can express energy, and you can solve this problem by using any one of them. You'll get the same answer. So Acer's not saying you have to memorize everything, but you probably should know one or more of these. And the other, which is probably one of the most famous equations in introductory level physics, is Newton's second law. And Newton's second law is that the sum of forces is equal to mass times acceleration. So this is related to an object that moves, is that if you have an object and you have a force acting on the object, that the force is going to be equal to the mass of the object multiplied by the acceleration. Because if there is a net force, it's not just that the object will move, the object must accelerate. So that's classical physics, okay? So that's Newton's second law. So these are the most basic equations in physics. So now let's look at the information provided to us. So the specific latent heat of a material is a measure of the heat energy per mass release absorbed during a phase change. So then I'm going to put up here 4 and 5 released. And so we are given the equation Q is equal to mL. The dimensions of a physical quantity can be expressed as a product of basic physical dimensions. So we're given that. And for example, good example, for example, the dimension of the physical quantity speed or velocity, which is meters per second, can be expressed in meters, length, second, time. So it could be presented as length over time. So which of the following would be consistent with the dimensional formula for the specific latent heat? Okay, so I have Q is equal to mL. Well, I'm going to write this as Q is equal to M latent. And there's a reason for this. On the real exam, sometimes Acer has some distractors or some kind of traps. That's what students will call them, traps. Acer wouldn't call them that. And I'll give you an example. There's been some past questions in which there are multiple variables that use the same letter. Now, this drives students with a non-science background, I wouldn't say nuts, but it makes them very uncomfortable. That in science books, sometimes the same unit or the same value is given different variables. And then sometimes the same variable is used for different elements in the problem. So all it means is that you have to be very precise. So I'll give you an example. Distance in science. There's so many letters to represent distance. Of course, D, small d, big D, but sometimes it's capital letter S for displacement. Sometimes it's in optics, it's I, O, F. It goes on and on, R. I mean, there's so many letters that represent distance, and it's the same distance. And in SI units, it's in meters. So, you have to look at how were things defined, and you have to pay attention. Because right away, if you see a problem like this, I'll just give you an example. There's a problem that Acer released in which it had multiple variables that used the letter T. So there was time, there was temperature, and there was something else that had capital T in the same problem. So you can imagine students are trying to solve a problem, and then on top of that, they can conflate information that is being presented. So right away, I could see that in this problem, capital L is for latent, but capital L is also for length. And I don't want to confuse them. So simple thing to do, I'm just going to write it. Okay, I'm going to manipulate this to latent. I'm going to divide both sides by m. And so latent is Q over m. Now I'm trying to find out what are the units for latent. That's why I isolated latent on the left side, because that's the question. Which of the following would be the dimensional formula for specific latent heat? So I put latent on this side, and then I want to see the formula. Now keep in mind, m is mass. So I have all kinds of energy equations. You see, the units for energy is joules. So it doesn't matter what equation I use. I can use any of them, and I still will get to the correct answer. So what the heck? I'm going to try kinetic energy. So I'm replacing the Q, which is heat energy, by another form of energy. I can do this because I know the units are the same. So I'm going to put 1/2 mv squared here over the mass. Masses will cancel. I end up with 1/2 v squared. Well, what are the units for 1/2 v squared? V is velocity, meters per second. Notice that information was already given to you. So this is meters squared over seconds squared, which is equal to L squared over T squared. And L squared over T squared is answer D. Okay, so it's written L squared T to the minus 2, because I said if you want to bring this up, you have to change the exponent. So the answer for question 4 is 2. Now, I know some of you are going to say, what happened to the 1/2? Well, the 1/2 is irrelevant with regards to the units. I'm just following the units, and this is what it's giving me. You could put 1/2 in front of it, but that's not the unit. The unit is not 1/2 m squared over s squared. The unit is m squared over s squared. What number is before that is a modifier. Okay, some of you might have tried another way. Instead of using 1/2 mv squared, you might have used mgh over m. Again, m's cancel. What is g? That's gravitational acceleration in meters per second squared. And h is height, is the distance, and which is the height. And the distance is measured in meters. So we have that multiplied by meters. And again, we get meters squared over seconds squared. And if you use force times distance, you're going to get the same answer. If you use FD over M, the force is mass times acceleration, and we have distance. So masses cancel. The acceleration is meters per second squared, and the distance is meters, and you get exactly this. So you get exactly that again. So no matter what way you do it, you end up with the correct answer. Okay, so then let's now you're graduating. Okay, now you look at question number 5, which is just a little bit more, because it requires another element of reasoning. So we have the force is equal AT to the minus 1 plus BT squared. And we have T is the time, and we want to know what the dimensions A and B, what would that be? Well, I want to remind you that over here, um, we established that force is equal to mass times acceleration. That's Newton's second law. So I know that force is mass times acceleration. So I'm going to write what that means. Mass, of course, can be signified by big letter M, and acceleration is meters per second squared, as we saw here. So acceleration is meters per second squared. So meters is length, and per second squared is t squared. Okay, so this is the force. Now I'm looking for what would this represent and what would this represent. Now I'm going to do this separately. I can do this separately. I can do this separately because I know that if you add two things or if you subtract two things, they must have the same units as this. So if this is force, you know, side note, unit of force is Newton because it's Newton's second law. So the unit force is Newton. And I know that this must be in Newton's and this must be in Newton's. When you multiply two things together, they can have different units. After all, you multiply mass times acceleration. This is mass, units of kilograms. Acceleration, units of meters per second squared. But when you add two things together, they have to have the same units. It's, you can't add apples to oranges. You add apples to apples, oranges to oranges in order to determine the total number of oranges or to determine the total number of apples. So to determine the total number of newtons, you add newtons to newtons. Okay, so then I'm going to look at this individually. I'm going to put A here, and this is t to the minus 1, so that means t is in the denominator. So I can write it this way. And then I just can cancel 1t here from 1t here. Then I have A is equal to ML, ML, and t in the denominator. And if I bring this up, it's t to the minus 1. A is ML t to the minus 1, which means the answer is D. Nonetheless, because we're here and you're having so much fun, we're going to just do B, right? So B, so we have ML t squared. This is Newton's. So this is Newton's. So it has to be able to be equal to B. And this is t squared. So T, big T, okay, symbolizing big T, the time squared. So this would have to be equal. And in order to isolate B and get rid of this, I have to divide both sides by t squared. If I divide both sides by t squared, then I get ML over t squared times t squared, which is t to the power of 4 is equal to B. So then that means that B is equal to MLT to the minus 4, because you couldn't bring that right up. Okay, so if it's the first time that you've seen this kind of thing, I'm hoping at least you can say that question number 1 was straightforward. I mean, what did you do? You converted centimeters to meters, and then you took the inverse of that. And that's the most basic mathematics you're going to see on the exam. And then other question types, yeah, it takes a little time to get used to it, to work through it. But how much physics did you have to study to be able to do this? Not very much. You know, as long as you have the basic ideas, basic units, and truthfully, it's secondary school, high school level physics. It's university level chemistry and biology, introductory level chemistry and biology. That's university level, but the physics is so basic, and that's why many students will just do independent study in order to get the physics necessary in order to complete the problem. Okay, so we're going to have monthly free webinars. Another one's going to be before Christmas, and we also have 3 hour long tutorials. Obviously, we go into much more detail and problem solving strategies and all of that. And of course, you can go to the website or to Amazon to look at the books or other material. And as I mentioned before, you can go to your library even to get access to some of the material. Okay, that's it for today. You can post your questions in the forum. Um, I wish you good luck with your studies and see you in the next one. Bye for now.